Hello, Dr. Mike here with Introduction to Operating Systems, Topic 3, which in this case is Desktop Virtualization, and currently, as of this recording, which is Chapter 3 in our text. So we're going to talk about virtualization in the desktop sense, but we will actually also cover a couple of different aspects of running different operating systems on a single system, or accessing an operating system remotely. So again, I have cherry-picked some slides. I have some links up here. I think I'm going to cover what I think is the important aspects of virtualization. So first off, what is virtualization? It has many forms. You could even say VR or augmented reality. Of course, gaming, about virtual worlds. Storage virtualization. I'm not going to cover that too much. Network virtualization. That comes to when we look at the cloud. But that's when the cloud comes into play. Network virtualization, again, cloud and also local, you create virtual networks, VLANs, as they're called. And if you get further into your education and talk about networking, you definitely will become familiar with VLANs. We're going to focus really on server virtualization. It's going to briefly mention what that is, but we're going to look at virtual machines and desktops. And I'll mention here application virtualization. There is clients that Microsoft has, a server and a client, and allows you to run applications virtually. And that sounds funny, but when you log into a system on the college campus, part of the login process is authentication, and then it authorizes you, and it will unlock certain applications that Windows system can run. It could be an application suite for writing code. So it could be a VMware suite or for other tools for your class. And these are served out, sort of fed out from our application virtualization server. Also, application virtualization, we could also look at cloud. So things like Gmail, eLearn, even for example. These are serverless applications that are served virtually through, in this case, a web browser. So just going to touch upon that. The chapter will probably go into more details on those things. Let's talk about some basic virtualization. And really, it's actually access. So let's talk about here, I love this image, 1970s era terminal, actually. Good old like VT200, green, black, green text on a black screen. Access. This access itself is not anything that's too crazy. It's still used today in a lot of ways. The idea here being, and it says mainframe, but it could be a server or mainframe. And we have a terminal client. And all this terminal client has in it is a small OS that really only allows access to a set server or whatever you tell it to connect to. So it has the protocols communication to talk to the server. So everything you see in the window on here, all those commands and stuff are really happening here. So now the image here you see is a 70s era computer terminal. We still use that in a lot of ways. Believe it or not, there's actually something called PuTTY. It is a client that runs on Windows, Mac, even Linux, that will access in the same fashion. Now it's not a huge machine like this, but it is just a window, it's an app, but it has the same access. You're accessing a server to perform certain tasks. So this hasn't really gone away. We replaced this big old huge machine here with just application. So PuTTY, P-U-T-T-Y. If you're going to get into any kind of system administration, especially Linux or cybersecurity, whatever, you can find yourself on the command line a lot, or interacting with an operating system via the command line. A lot of times it's going to be Linux on the back end here. PuTTY, P-U-T-T-Y. Learn that one. You're going to be using it. So now terminal services and terminal clients. So what is that? So again, a terminal client is really, it's not really a dumb terminal. We see this. Windows has a special, I think it's a CE client or Windows Client Edition, and we have a Windows Server back here. So where you see this at? A lot of times, maybe point of sale systems. The point of sale system itself talks to a server, which has, of course, this is where you keep all your data. So our database is on here. So this is locked away, hopefully secured, physical, networked, everything. This is secured away and only allows access from one or more of these Windows CE clients. Another place you see this too, doctor's office. You might notice if you ever go to the doctor's office, they have a small little tiny PC, like, no larger, maybe just a little larger than a phone almost, just maybe a couple, maybe twice as big and maybe twice as thick, but still small, plugged into the wall, and you'll see a Windows login. Usually maybe a fingerprint login and or some sort of multi-factor authentication. And what it does is it runs a remote desktop, or called a thin client, into the medical records. And again, our medical records are stored in a secure location, and then all those doctor's offices, maybe there's a couple dozen, have these serve terminal services client. The idea is if something was to happen, maybe someone broke in and they stole those, all they have is the hardware. The medical records are locked away, hopefully in a secure location, either in the cloud or at least in a locked away locally. So this is used still in a lot of places. I think that's what a thin client. Thin client is this sort of dedicated terminal with client software. So I covered that already. Let's clear this out here. All right, now let's talk about actual virtualization. So virtualization itself, I'm going to really focus more on desktop, but it does sort of play in with also enterprise level. At least these terms do. So local virtual desktops or virtual machines. So the term VM, a virtual machine, we're going to see that a lot. We're going to see this term here, host OS and guest OS, or host and guest. So what is that? So let's just take a system here, and we have underlying hardware, right? We have a hard drive. That's supposed to be a hard drive. We have, of course, multi-core CPU. And we have RAM. And we have a network connection. I'll do my best to draw a network card to the outside world, right? Just put a cloud out here. That's the outside world. So, of course, on your operating system, you have an OS installed on your computer, right? Your system. Excuse me, your PC or your laptop. You have some sort of operating system installed. So let's just say Windows 10. It could be Mac, Linux. So this is our host OS. This is your main operating system. And we're going to see here we can host with specific software. I'll just draw that here for now. In a container. These are called guest operating systems. And you can have actually many of them. Here's guest 1, guest 2. And these can also be, again, either another version of Windows 10, it could be Linux, you name it. So host OS and guest OS. So again, real important thing here, host OS being the operating system that runs on the actual hardware. Guest OS being the virtual machines. So you can see here, there's a VM here running. Looks like Windows 7 on a Mac. So we'll come back to that and sure, move on. Okay, so this is probably more important too. Type 1 and Type 2. So hypervisors. So before we jump into and talk about hypervisors, let's talk about a couple things here. Go back here. There's remote desktop clients. This is a Windows Microsoft document page for remote desktop clients. Again, this is a way to, again, access remotely a system like I showed you before. It could be used or PuTTY. Sometimes it's a virtual desktop. Sometimes it's just a virtual terminal. So Microsoft has this here. And before we jump in and talk about hypervisors, and virtualization is something called dual booting. So we see this a lot with Windows, Linux. Sometimes someone has maybe a laptop or a desktop where they can boot into either separate OSs. So again, we have our hardware down here, RAM, CPU, network connection, and our hard drive itself, let's draw that little container there, might be split somehow. It's partitioned to allow two operating systems that run directly on the hardware. So it could be Windows and Linux. That's supposed to be an X. There we go. Excuse my horrible scribble there. The idea here being you can boot your system. Then we have a bootloader here. Our bootloader will determine, ask you, do you want to boot into Windows or Linux? For Mac, it has something called Boot Camp. So again, you can actually boot into Windows 10 or Mac OS. So you gotta consider two things here. Now, we're talking about Mac or with Boot Camp, or we're talking about just dual booting. What are the positives and negatives of doing this? Well, first off, the positive about booting into an OS is that operating system has full access to the underlying hardware, full access to all the CPU and its cores, full access to the hard drive that's been given at least. So direct, read and write access. It's quicker. It's gonna be a lot faster. Direct access to network and memory. All the memory is there for it. If you have 32 gigabytes, it has full 32 gigabytes. So a lot more powerful, but a lot less convenient. And you saw in the textbook, if I launch, a VM, a lot more convenient. So virtualization is a lot more convenient. As you can see after it boots up here, I can access, in this case, Windows and Mac very quickly, and I don't have to reboot my computer. So there's more power in dual booting. It's more convenience in virtualization. So keep that in mind. It's going to depend upon your use case. You might find that a virtual machine is going to be fine for most tasks, whereas maybe I need more underlying power, whether it's for maybe video editing or just gaming or whatever. I want to boot into that operating system directly. So that's annoying. Go away. Oh, Windows. Pause you for now. So come back to the virtualization there. So that's called Boot Camp, or just dual booting in general. All right, so let's talk about hypervisors. All right, let's go back and talk about this right here. First off, again, I'm going to draw here. We have some underlying hardware. We have hard drive. We have a CPU. Don't forget it has multiple cores. And we have our random access memory, our RAM, and we have a network connection. Let's put it in there. So this is our underlying hardware, or it's referred to as the bare metal sometimes. So we have an option here. So there's type 1 and type 2 hypervisors. So first off, what does a hypervisor do? Hypervisor is going to give access to, I'm going to draw a virtual machine up here. It's going to give access to the virtual machine to the underlying hardware. Of course, it could be a part of the hard drive. It could be one or more CPU cores. It could be some of the RAM. And it can offer a network connection. So we have our hypervisor here. So of course, it's going to manage the virtual machine, and it is going to allow it to run either one or more operating systems. So that's the job of hypervisor, is to host the guest OS. Now, again, you can see here I can't access my full CPU. If I give my virtual machine all my, let's say I have 32 gigabytes like I have on this machine here, I can't give all 32 gigabytes to my virtual machine. It will kill my host machine. So I can only allow so much access to hard drive. I can give it so much of my hard drive, only so much of my CPU, that being so many cores, maybe 1 or 2 cores if I have multi-core CPU. Network access is pretty much straightforward, but there's an option there. I'll talk about that in a second. So that's what hypervisors do. Hypervisors, they manage the guest operating systems and allow access to the underlying hardware. So second point here, the type of hypervisor, type 1, type 2. So type 1 is usually used for enterprise levels stuff here. So type 1 does not need a host OS. So type 1 will run directly, it actually installs like an operating system. And these include Citrix, Microsoft, Oracle, Microsoft has stuff for this, VMware, KVM on virtualization, VMware is another one, Oracle, VirtualBox. We'll come back to those real specific here, but if I show like ESX server, ESX server is a good example of this. You can see here, it runs, there's an operating system installed. So ESX server actually runs right here on top of your bare metal. Now again, this is very expensive, and this is really used more for enterprise level stuff. Because first off, it offers more access to the underlying hardware. There's less overhead. If you run Windows 10 and you're running your hypervisor there, of course, that would be a type 2, where it doesn't need to have a host OS. Windows is going to do a lot of stuff in the background. It's going to take a lot of memory. So this ESX server is a dedicated hypervisor, type 1, and it allows all kinds of options. First off, it has some really cool features here, which I don't know if this thing will tell us. One of the cool features that I've seen, they demoed this when I was working at Reynolds, is you can be running your server. So let's say I'm on a virtual server here, and I have multiple systems. Let's go and just draw this out here. So you think, oh, so what's the advantage of type 1? So again, a type 1 hypervisor. So usually what you have is a bank of 1 or more, definitely many servers. So this is my virtual machine server. Again, it has a CPU, it has disk, memory, and network, right? Each has the same thing. These actually, of course, are going to run maybe 2 or 3 or more. Again, this is server grade hardware, right? 120 gigabytes of memory, multiple CPUs with multiple cores, and so on. Maybe I got a couple here. So think about this ESX server. It runs directly as a type 1 hypervisor. There's no underlying OS, and there's probably a management server here somewhere. Actually, there's probably multiple of those too, to be honest. Keep backups running. So again, so what's all the deal behind this? Why is it cool to spend all this money and have this running and don't worry about having an underlying OS? So one-off patching and stuff here is going to be a lot easier. But second is, this thing controls this bank of servers. So let's say this hardware here, with this one server, is having issues. Maybe we have a problem with our disk is going bad. We get server alarms. And this is running. Maybe this is our shopping. Maybe we run a website off this and we sell stuff. If I shut this down, I'm going to lose sales. Well, with ESX server, I can actually take this entire virtual machine and migrate it over to another one while it's still running. And then it's gone from here and it's running here. So there's no loss of operations. Now you can see the power of this, right? And this is definitely used for cloud providers. This is in data centers. A lot of power behind this. The ability to move an entire running server from system to hardware platform without having to shut it off is going to offer some great availability. And availability is a key metric when you look at enterprise grade hardware. So again, ESX servers type 1. That's an example of type 1. Type 2, though, is one we're looking at here. Type 2 is your most common desktop. Things you're going to see you would actually use this as a student. You might use it at home on your laptop or your personal desktop. So it comes in all kinds of flavors. Citrix, Microsoft has their own called Hyper-V, Windows 10. So again, look at the documentation from the provider for more details. The textbook might talk about a little more in detail also. Hyper-V Windows 10, KVM on Linux is a big one. KVM actually almost borders into ESX, more enterprise level stuff, and it's free. So, but KVM on Red Hat and other Linux providers. More one that's pretty common if you have Mac is Parallels. This is a Mac only. Again, it offers some enterprise level power, but really it's its ability to run a virtual machine on Mac. Two common ones that we'll talk about here. Two common type 2 hypervisors, which again, let's just review this real quick here. Again, I have my hardware layer. I need to have a host OS for type 2. And then type 2 is going to run my VMs, my virtual machines. So type 2 needs an underlying OS, host OS, Windows, Mac, Linux. Again, and it does the same thing as I saw before. This is going to share out some of the underlying hardware and manage those virtual machines. So very important. Type 1 does not require underlying host OS. Type 2 does. So that important point out here is talk about. Before we talk about the steps here, let's talk about the providers. Two of the major ones here, VirtualBox. This is free. It's a fantastic one. I believe this class you actually, in a virtual machine, you actually will install VirtualBox as part of the labs for this week. So you see screenshots here of it running. It runs on different ones on Windows, Linux, Mac. Fantastic one. VMware is licensed. A lot of times you can get a license, I know through the school sometimes, for a one-year license for free while you're a student. Or you can buy one. So again, it has a lot more solutions here. There's VMware Player. There's multi-cloud stuff. So they offer a lot more different things here. I won't go into that. Again, look at VMware website for more details. But VMware does have clients for Mac and Linux also, believe it or not. I actually have a Linux laptop that has VMware, and I also have VMware and VirtualBox running on one client. So let's just take a quick peek at the underlying parts of a Type 2 hypervisor. So again, you saw me, I'll launch Windows 10. This is VMware Fusion, the VMware product. What you're going to see screen-wise really is the same on VirtualBox. It just looks a little different. Some stuff might be different, but in all virtual machines have settings. So let's go and take this mouse boy here. So whether you right-click or use a menu on the item itself, your virtual machine has settings. And again, it's going to look different on VirtualBox, but all in all, again, same stuff here. You have the main settings, of course, is processor memory. How many cores do I want to give it? How much memory do I want to give this underlying virtual machine? Again, 512 megabytes here, it says below. So you know what? Let's make it 1024. So there you go. Now going again, some of these things, if you change them, the machine needs to be shut off before it can be changed. And most of the hypervisors like VMware or VirtualBox won't let you change things. It'll be grayed out if it's sort of paused like I have here or running. So again, you can change memory. Pretty great ability though. I can actually take a virtual machine and just add more memory to it or add more processing cores. So 1024. Can't type there out. You can also have one or more network adapters. In this case, this is Metasplittable 2. This is I use this for basically pen testing training or trying my tools out. It's a Linux distribution that's very, very vulnerable, so you can definitely hack on it. I have different network adapters. I actually have, and we'll talk about network in a second, one for internal only and one that can point externally. So network adapters themselves either call, again, we'll come back to that in a second. I don't want to go into that now. Hard disk, how much hard disk does it have? You notice that the hard disk itself is actually a file. So virtual hard disks are really just files on your host operating system. And they can be very large. We'll talk about that in a second. USB, isolation, encryption, startup is a lot of information here. What is exploitable, how big it is. So again, you can manage, clean up, alter, and edit your underlying virtual machines. Or you can even add devices that can add a virtual hard drive. So again, this one's shut off, so I changed it. It worked. And this Windows 10 one is actually sort of running already. So I can't change the settings. Like watch, if I go to, you notice it's grayed out. I can't give it, right now I give it 8 gigabytes and I have 2 processor cores. Again, it says you cannot change this. This will be the same with any virtual machine. You really can't alter that, but you can alter some things. I can actually change the network adapter while it's running. I might need to balance the network settings within the guest operating system for that change to interact. I could maybe change the sound card while it's running. Let's talk about USB. So a lot of times when I plug in a USB device, if you have a virtual machine running, it will ask you, do you want this to connect to the host OS or the guest OS? And if so, if you have multiple guest OSs, which one? So look at that in your settings. And that, of course, would be under the settings for your actual virtual machine. So the actual hypervisor settings themselves, VMware, again, VMware or VirtualBox, you'll have some generic settings. What to do if you close a virtual machine, keyboard and mouse, you can map controls, how do you want to do the display. So again, you have general settings for your hypervisor, and you have specific settings for your guest operating system, default apps, network settings. So again, it's going to look different. I close the tab on VirtualBox. They had screenshots, which I should have left up, which is tiny. Horrible looking screenshot. But it's going to look a little different, but it's the same stuff. So whether you're in different operating systems, VirtualBox really have the same underlying functionality, just given to you in a different way. Let's talk about some aspects of our virtualization here. So we talked about the ability to share, of course, your disks. So again, we're going to take one virtual machine here. We have a host OS. Here we have, again, our hard drive, CPU, RAM, and I'll put the network card over here on the side. So of course our host OS, we know that it connects to our network card directly. We know our VM, it can be written to disk. The configuration of the virtual machine, settings, details, and also again the virtual hard drives, which can be pretty large files. They'll grow as needed. The VM's going to use that, of course. We have our hypervisor here. This is a type 2 hypervisor. So again, it's going to allow that. Maybe I give it, again, maybe we'll give it 2 of our cores. That's going to come through here. And we're going to give it some RAM. Maybe I have 32 gigabytes. I'm giving it 8 gigabytes in this example with Windows, and so on. So network. How's networking work? Play on words there. So networking with virtualization has a few modes. So for the default mode is this. It's going to use something called a NAT, a network address translation table, a NAT, or it's going to be called a shared network, where it's actually going to come in. Hypervisor is going to actually pipe it through the host OS. It's going to share the same network adapter here. So a NAT's going to use that. It's going to use the same network adapters. That means if you have a home router, all it sees is Windows 10. Let's erase that. Our network router at home sees Windows 10 logged in. That's all it sees. All the traffic comes through our host operating system. For most of the time, that's fine. That's all you really need. So a shared network or a NAT setting, which is the default on most hypervisors, is all you need. Now there are some options though. Let's just clear this out here. So if we do want to come across something called a bridge network. So our network comes in. A bridge network or a dedicated network, Hypervisor actually creates a connection to, and let's say our virtual machine is Linux. Our guess is Linux. When it comes out of our network port on our actual hardware, it actually looks like a different operating system. So it comes out our network, and we see it out here on our local network as a different Linux. We'll see Linux out here. Let's see the Linux OS show up as a different machine. It's almost like if the actual machine was sat down and plugged into the network or connected to the Wi-Fi as a separate actual virtual machine or a separate system. Now, do you need this for most of the time? No, you don't. This really comes into play if you need to somehow connect back into the virtual machine, whether we're using like a remote terminal or remote desktop. Because with the NAT, it's going to cause a lot of issues. It can be set up, but it gets a lot more complicated. So a bridge network is something you can do. So a bridge network. And the last one is we can actually have a private network. So we can actually have a network that's only within, sort of held a virtual network within our actual host operating system. And this is what I use a lot because I have a couple of VMs I might run at one time, maybe 2 Linux. An example, I had a Metasploitable Linux here running. It connects to a private network that is can only be seen by other virtual machines on the host. And this is because I don't want this to connect to the outside world. A lot of times, maybe I'm going to run malware analysis. I definitely don't want that thing connected to the outside world. Again, I'm running a machine, a system, a guest system that is very vulnerable for testing, for example. I need to connect to it from another virtual machine, but again, I don't want it to connect to the outside world. So I can create this sort of host-only operating system. And I think you saw it here. If I look at Metasploitable Linux, look at the settings. I have 2 network adapters. This one is private. This is a NAT. What's this one set to? This one's also private, so I have to look at the advanced options. But it's not uncommon if you're going to do any kind of cybersecurity work or malware analysis or forensics work, you might have a network adapter that's only local only. But again, like for Windows here, the default NAT or shared network is the most common. Again, you can see, you can change. I can even change it here, private or shared. So there's bridged network right there, bridge network or shared network. And here you see the word NAT. So virtual machine shares IP address with the MAC on the external network. And now, so the MAC address, which you don't know what that is right now, you'll see that later. And IP address are the same as my Mac OS, my host operating system, and my guest operating system really work on the same IP address at Mac. So, all right. So important aspects again. Quick review here. Type 1, Type 2 hypervisors. Understand that. Understand there's a VirtualBox, VMware, as well as KVM for Red Hat, ESX server, things like that for Type 1. So a couple of quick steps here before you install your host operating. Before you install any kind of virtualization, there's sort of some steps you want to go through. So first off, pretty straightforward here. Prepare your host computer. This means going through and understanding how much hard disk space you have. If you're running Windows, it could be looking at your drive and your memory. If I'm running a Mac, I might want to go in here and see how much storage do I have left. Because normally you might store by default, you will store your guest operating systems on your main drive. So make sure you have space. These things take up a lot of space. Also, how much memory do you have? In this case, I got 32 gigabytes. And of course, make sure it's a pretty modern OS. What kind of processor do you have? The idea being, if I have an old laptop that has maybe a dual core CPU with 1 gigabyte of RAM and maybe a 500 gigabyte hard drive that's almost full, this is going to become a problem. Again, if I'm in Windows, you want to go to like this network, this PC, and you'll want to look at the underlying hard drive space. So here I have, I got 54, I got 46 gigabytes free. That wouldn't be enough. Again, this is a virtual machine, but if this is a real operating system, this could be an issue. And of course, you want to look at just about the computer itself, your system itself, how much RAM do you have installed, what kind of CPU do you have, things like that. Now, some operating systems, virtualization is going to rely upon the underlying hardware to be set to virtualize. I don't want to get into the details of that. VirtualBox and VMware have details on that, and if you see an error saying you cannot do virtualization, it means you need to actually go into your BIOS on your computer and check or turn on virtualization. So those are settings that are actually in the computer itself, and actual hardware. So again, so there's hardware, and in most modern systems you buy will have this on by default. But if you have an older computer, it might not allow virtualization. So look at the documentation for either, again, your hypervisor provider, again, VMware, VirtualBox, things like that, to go and tell you how to check for that. So that's preparing the host computer. A lot of it is just understanding how much space you have. Download Hypervisor, install it. Pretty straightforward install, step by step. You go through it. Create a virtual machine. So when you create a virtual machine, most hypervisors will have a step-by-step process. One of the things you need to have is an ISO file, which is your underlying or your actual operating system you want to install. So we'll bring up an ISO file in a second. Okay, so let's take a look at what an ISO file is. Very important thing here, and it's extension.iso. It really is think of it as a disk image. I know a lot of new systems now don't actually have DVDs or CDs anymore, but think of it as an image of a DVD or a CD-ROM image. And of course, we have the file name .iso. So it's sort of what it is. Pretty standard. A lot of times now you can use, if you download ISO, you can burn the ISO to a bootable USB without actually having to use an actual plastic, the old DVD or CD itself. Things like Etcher, for example, will actually create a bootable USB from an ISO file. So besides that though, you do need to have your ISO file for your operating system you want to install. So first here we'll see, this is NetLabs here. We have VirtualBox installed. We'll go ahead and say run. A couple security checks here from, there we go. So this is a VirtualBox setup. Next, I'm just taking the defaults. That's fine. It's going to ask to allow access to your network card. That's what that previous screen was. Again, security check from Windows. That's fine. Yes. Again, we're going to install and trust. That's it. So I'll uncheck that for now, though. So we can see there's actual VMware. If I start that, we can see our VirtualBox. So when you create a virtual machine, pretty straightforward. You do new, and you want to say, you give it a name, any name you want. Call mine Dr. Mike, Dr. Mike OS. Where you want to put it at. So if you have a dedicated folder, you can go and create your own if you like, and you can go into the settings of your hypervisor and actually say make the default a different hard drive, maybe an external hard drive if your main hard drive is getting full, or you want to make them portable, or you just want to have that space taken up somewhere else. So again, default would be you're basically on your home directory. So even on my Mac here, I have a VM folder. You can see there's 3 VMs here: Kali, SIFT, and Windows 10. So you'll see what it is too. So you want to give your virtual machine sort of a hint. Hey, by the way, this is Linux. If you're not sure what kind of Linux it is, what flavor it is, or if it's Windows. Maybe you make another Windows. Is it Windows 7? Maybe it is Windows 7 32-bit. Is it Windows 8, XP? So you want to tell it because it's going to make the hypervisor allow this to create the settings it needs for that guest operating system. So again, let's just say Linux. And we'll just say other 32-bit. So remember now, we talked about this before, architecture in previous lecture. 32-bit architecture versus 64-bit architecture. And you're going to see this a lot when you go looking for ISO files. You'll see this. Sometimes it's shown as either x86 or 64, x64, or some kind of spelling like that for 32-bit and 64-bit. Very important. So first off, you don't want to make sure you can support whatever you have. If you have an underlying 32-bit host operating system, you're not going to be able to run 64-bit guest operating systems. Chances are, if you bought a computer within the past few years, you're going to be 64-bit, and you might want to get 64-bit guest OS. And so, before we look at that, you need to have your ISO file. But again, we'll go ahead and finish this up here. Give how much memory you want. You can slide that from our 2 megabytes to say. Create a virtual hard drive now. What type of hard drive file system? Again, most of the time, take the default. If you're not sure, you can always research the help docs. But what is a VHD, VMDK versus VDI? And this is pretty important. So how do you want to create your virtual hard drive? Fixed means if I gave it 60 gigabytes, it's going to create 60 gigabytes of space and sort of mark it as used. Whereas dynamically it says, well, I'm going to earmark 60 gigabytes, but if I only need 40 gigabytes or 30 gigabytes, I'll actually will use that on your host operating system. So it won't actually use all 60 gigabytes. So again, it's up to you how you want to do that. Most of the time I take the default, dynamic's fine. It's going to ask you what you want to call it. You can see it's going to create a VDI file. And there it is. So now again, if I run, I don't have Linux here yet. So I will need to actually sort of attach this ISO file. Now let's talk about ISO files. So let's first off, what they look like. So there's one actually here in Documents, ISOs, called Puppy Linux. So you can see this is pretty small one. That's 270 by 270 meg, which is pretty small for a ISO file. This is called Puppy Linux. It is small, and it's called a .iso or disk image. Now, these get really large though. So where do you get these from? Depends what operating system you want. If you're downloading Windows 10, you'll get a Windows 10 ISO file. That can be like 4 gigabytes in size or more. If you're downloading, say, Linux, you see Kali Linux here. We have Kali Linux 32-bit or 64-bit. This is the installer version. This is sort of running live. A live version runs from the ISO without installing to the underlying hard drive, whereas the installer will install to the underlying hard drive. When I say underlying hard drive, I mean the virtual hard drive. So you can have a bootable Linux OS here. In this case, this is 3.7 gigabytes in size. This one's 2.6 gigabytes. So these are pretty large files. You can either download them. It's going to start downloading. Let's cancel that. I don't want to install that now. You can download the actual ISO file directly from here. Sometimes you can go here. You can see, here we go, x86 64-bit. There's other ones too. Here we have 32-bit for ARM. So I have to understand your underlying architecture is pretty important. This is for CentOS and another Linux OS. Here we see i386. This is 32-bit. x86 64 is 64-bit. So look at the documentation. Be sure you're downloading the correct ISO file for your install. So again, Puppy Linux, here's the ISO file. It's been downloaded. Quick note, if I download a Windows 10 ISO file, it does need proper licensing. So you might be able to run it in temporary mode, I think. But in any case, make sure you have the right licensing for your licensed OSs. Most of the time you're going to take in your system and you're going to sort of attach in the CD-ROM tray. You will attach and you'll choose a disk file. In this case, was it Documents, ISOs, Puppy Linux. And this will sort of attach this ISO file, almost like virtually putting the CD-ROM or the USB into the device, and then when you hit boot, it will actually run the installer. So a quick note here, that if you're doing this, you're following along with this in the virtual machines we have for the college, you can see this error comes up. So you're not going to be able to actually hit the OK button, and it's because, again, there's no underlying support for virtualization in our virtual machine. So, but in any case, that is how sort of attach that. And if I was to start it, it would almost be like turn the machine on. It would boot off that ISO image, and we can start the install process or run from the image itself. So pretty important, our ISO file. Now we know where to get that from, and that's where we get our. That's part of our preparation. And then we install our guest, and then there's actually utilities you can install also. So example, there are things called add-ons. It's going to depend upon your virtual machine hypervisor. VMware has different names versus VirtualBox, and it's going to install a sort of a small piece of software in your guest OS that allows it to communicate with their host OS and gives it better functionality. So here we can see there it is, VMware Tools. So VMware Tools, when you install this, it gives you things like the ability to create a shared folder on your guest OS, on your host OS that the guest OS can access, or I can copy and paste stuff from one to the other. Otherwise, or I can do things like this. I can create a sort of view full screen or Unity screening. Unity screen does this. It sort of puts the operating system sort of has put it in my host and my guest are now the same operating systems. So you can sort of blend them all together. So go back to full screen here. So there's a lot of stuff you could do. Do this if you're going to use the underlying operating system for like daily use. If you're just going to just try it out, you could probably just use the defaults, and that should work. So again, VirtualBox, one of the really good ones to use. I would suggest using that. It's free on Mac. You do have Parallels, VMware, or Boot Camp. And that's it. That wraps up virtualization. And again, refer to the text here, our textbook, for any details I may have missed. But I believe we covered the main stuff. I think the biggest parts are understanding types of hypervisors, how they work, and the steps you use to go ahead and install and create your virtual machine. And that should do it.